Section 4.7, inverse trigonometric functions. These are the objectives. You can pause to read them, but I'm moving on to the next slide. This is the vocabulary key concepts: inverse functions, alternative notation, domain, range, and composition. Before we go to the next slide, let me kind of give you an idea what you're going to be working with in this section. At this point, if you look at this, tangent of theta is equal to 1. So in other words, I want you to give me a theta that satisfies this equation. You want to be looking at the unit circle. Look at the degrees. So tangent of an angle that is equal to 1. And notice, once you look at the unit circle, you're going to have tangent of 45 gives you 1. And also, tangent of 225 gives you 1. So in this video, in this section, there's going to be a restriction made so that only one of these two thetas is the answer. Okay, so let's move on to this slide. Since this is definition of sine inverse trigonometric function. Okay, you can see the function, domain, and range. Let me just kind of talk about the function. Pen. So this is what I'm going to ask you to do. Just for a while, let's consider, I don't know, pi over 4. And then sine of pi over 4, you know it is equal to radical 2 over 2. If you plug it in here, notice that you're going to get the same thing. So arc sine of x, which is radical 2 over 2, is equal to pi over 4. And notice that this is a biconditional statement, if and only if, which is on geometry. So it goes forward and backwards. This arc sine of inverse, this is representing the same thing as y equals sine inverse of x. Okay, these two represent the same thing. It's just expressed differently. This is alternative notation for sine inverse. Notice that the domain is -1 to 1 on the x, and the range is from negative pi over 2 to pi over 2 on the y. Now let me show you, let me get rid of this. Let me show you the graph that corresponds to this inverse trig function for sine. And notice this is what I was talking about earlier. Sine inverse of x is the same thing as that. It's just alternative notation, different notation. But anyway, and notice that the domain, x values from -1 to 1, the range from negative pi over 2 to pi over 2, and this is representing quadrant 1 and quadrant 2, quadrant 4. And notice that we're not looking at, I don't know, what's it called, 7 pi over 4 in quadrant 4, nor 11 pi over 6, those angles in quadrant 4. We're looking at negative pi over 2, negative pi over 4, negative pi over 6. Okay? And notice this is how the range is expressed. From negative pi over 2 to positive pi over 2. It's very important that you catch that. So now, just to illustrate something, I want you to get this confused. Sine inverse of x, this is not the same thing as sine to the -1 power of x, which means that it's not equal to this, okay? Important that you understand this. Moving on to the next slide. So now I'm going to define cosine inverse. And again, here's your notation. You can plug in an angle for y, and you should be able to get a value for that angle, and then you can go back and it should make sense. The restriction on the domain for cosine is the same, but the range changes. If you look at the graph, this is what you get for the graph of cosine inverse. Okay, now let's look at the quadrants. This is representing quadrant 1, and this is representing quadrant 2. So this is definition of tangent inverse trigonometric function. This is how we define the function. And again, you can plug in y and x here like the previous two examples, and you should get something that makes sense. Notice the domain is very different. Here you're going from negative infinity to positive infinity. The range looks very similar to the range for sine, except for the equal to, and this is the graph. And this is representing quadrant 1, values in quadrant 1, and this is representing values in quadrant 4, but notice that you want to follow this restriction from negative pi over 2 to pi over 2. So now, how do we end up with the graph of sine, cosine, and tangent inverse? And it has to do with something you saw in Algebra 1. If you look at the graph, let's assume that we're working with y equals the square root of x. The graph of this looks something like this. Let me change the color. It looks something like this, okay? Now, to generate the inverse, the graph of the inverse, if I know the graph of the original, change the color here to blue. What you saw in Algebra 1 and also in Algebra 2, you get the line y equals x. And then what you're going to do is you're going to reflect this graph, the green one, about this line, and you end up with your inverse. Use red again, and it should look something like this. So this is basically what we do to, this is how we generate the graph of sine inverse, cosine inverse, and tangent inverse. Now you're going to notice that we have restrictions, and there's a reason why we have a restriction on all three. And if you talk to me in class, I'll tell you why. But again, this is something that you also saw in Algebra 1 and probably the first chapter of Algebra 2. And it has to do with this keyword, function. Okay, I'm moving on to the next slide. Composition of functions. And you did this in Algebra 1 and Algebra 2. And remember this, f inverse turns out to be x, or f inverse of f of x turns out to be x the majority of the time. But well, this is not going to be necessarily true in math analysis, of course. So let me just show you what this is saying. So now, sine of sine inverse of x is equal to x only if the x follows this restriction. In the same manner, sine inverse of sine of y is equal to y if y follows this restriction. If the y doesn't fall under this restriction, then it's not necessarily true. Same thing for the x. And you have the same thing for cosine, and then you have the same thing for tangent. And I'm going to show you how to basically work through the problem, and you don't have to worry about memorizing these three restrictions that you have for sine, cosine, and tangent, and the inverse functions. Okay, so here we go. It says find the exact value of each expression without using a calculator. So we have y is equal to our cosine of 1/2. Now let me remind you that this is the alternative notation. You saw this in geometry. So this basically implies the same thing. Now if you remember, what is this asking for? Cosine inverse. Inverse trigonometric functions always generate angles. So I'm asking for an angle here. Okay? So let me just get rid of this. So this is what I'm going to do. I'm going to rewrite this as cosine of y equals 1/2. And this is something, just working with the notation that you saw in, you learn about this in geometry. If you didn't, this is what it means. We can rewrite this expression the following way, because it represents an angle. So cosine of what angle is equal to 1/2. So now if you look at the unit circle, this is what you get. You actually have two angles, pi over 3 and 5 pi over 3. Now, what is the answer? Well, it has to do with, since we're dealing with cosine inverse, we have to remember that cosine inverse has a restriction for the angle, and is between 0 and pi. This is why the only answer is pi over 3. Moving on to number 2. Y is equal to arctangent -1. Y is equal to tangent inverse of -1. So I'm going to rewrite this the following way. Tangent of what angle is equal to -1? So if you look at the unit circle, you're going to notice that you have 3 pi over 4, 7 pi over 4. This is second quadrant. This is the fourth quadrant. And this is also in the fourth quadrant, but this is coterminal to 7 pi over 4. Now, let's go back to the restriction for tangent. For the y, you saw earlier, is from negative pi over 2 to positive pi over 2. This is why the two answers that you're going to eliminate are those two. So this is your answer. Notice that it's coterminal with this, but you want to express it as negative pi over 4, not positive 7 pi over 4, because it doesn't fall between this in this range here. 3. Same thing. Rewrite this using writing this. Sine of y is equal to negative radical 3 over 2. If you look at the unit circle, at what angle do we get negative radical 3 over 2? And we have 4 pi over 3 or negative pi over 3. Now, which of these two is the correct answer? We go to the restriction, and this tells you that you need to cross out this answer. So we're done with 3. Let's move on to the next slide. It says use the properties of inverse functions to find the exact values of the expression. So this is what we're going to do. I just want to highlight something you saw earlier, the yellow portion of the slide. We dealt with composition of functions. This is what you saw. And notice that you have sine inverse of sine. So let me get a pen. Sine inverse of sine. So we should be working with this portion right here. But this is true when the y is in this restriction. Is the y in this restriction? The answer is no. That's why the answer is not 7 pi over 4. So what we're going to do is we're going to focus on this. Look at the unit circle, and you know that you get negative radical 2 over 2. So all of this now becomes negative radical 2 over 2. So then you need to compute this, which is something you saw on the first 1, 2, and 3, previous slide. So sine inverse of what angle gives you negative radical 2 over 2? You know it's in quadrant 4. That's why the answer is negative pi over 4. Moving on to number 5. So now we have same directions. Now we have cosine inverse of tangent of 3 pi over 4. So basically what we're going to do, since we have cosine and tangent, I'm just going to break it up the following way. I'm just going to focus on doing this part of the problem first. Tangent of 3 pi over 4, you know, is equal to negative 1. So now I have cosine inverse of negative 1. Cosine inverse of negative 1, you know the restriction for cosine is between 0 and pi. So what angle gives me negative 1 for cosine? It turns out to be pi. This is your answer. Number 6, sine inverse of negative 0.1. For this one, this is what I'm going to ask you to refer to. This is what you saw earlier. Notice that I have this. In this case, sine inverse of x is equal to x if the x is between negative 1 and 1. In this case, this is your x, and of course is between negative 1 and 1. That's why this is the answer. Moving on to number 7. It says find the exact values of the expression. Hint, make a sketch of a right triangle. So we're gonna be working with this first. Remember, this is sine inverse arc sine 3/5. This represents an angle. So what I'm going to do is I'm going to let this equal to theta. And then from here, you learn to do this in geometry. This sine of theta is equal to 3/5. This implies the same thing. You also saw this in the definition of sine. Sine inverse. Remember that biconditional statement? Okay, so then from here, I need to keep in mind of where theta is. Now theta is between, sine inverse is in first quadrant and fourth quadrant. So since I have a positive ratio, I know that theta is in quadrant 1. Remember, this is the restriction that you have for the theta or the y. From negative pi over 2 to pi over 2, which is quadrant 4 and quadrant 1. So now from here, I take this information and I'm going to sketch a right triangle. Opposite hypotenuse, I'm able to find the this side here, which is 4. And then all I need to do is I have secant of, now all this right here represents theta. So secant of theta, go here, is equal to hypotenuse over adjacent, which gives you 5/4. And you're done with number 7. Moving on to number 8. This is the last problem. Very similar to number 7, same directions. I'm going to same approach as number 7. I know this is representing an angle, so I'm going to let this equal theta. What you learn in geometry or the definition of cosine inverse, I'm able to generate this. From here, I need to identify where the theta lies. Now notice that I have a negative ratio, and I know that theta for cosine inverse, theta is in quadrant 2. Why? Because cosine inverse is from 0 to pi. Quadrant 1 and quadrant 2, since I have a negative ratio, it has to be in quadrant 2. Theta is also negative for cosine in quadrant 3, but it doesn't follow this restriction that we placed on cosine. That's why we don't say quadrant 3. Then at this point, I'm going to generate a right triangle. This is what I get. Keep in mind that I'm in quadrant 2, and I'm able to generate the missing side in this right triangle, which turns out to be radical 5. And I'm computing tangent of, I let all this equal to theta, so I have tangent of theta. So tangent of theta is equal to, in this right triangle, opposite over adjacent, and that's how I end up with radical 5 over 2. Why do I have a negative? Because theta is in quadrant 2, and I know that theta is negative in quadrant 2. This concludes lesson 4.7.